Well, as you see, the topic of my presentation is quite clear. It's Full HD voice, which basically is a nice marketing name for our super wideband codecs. To give you an outline of my presentation today, basically, what's the motivation for using super wideband, and also what we understand by this concept. I will then go on to introducing the two most promising solutions in this area, which are the EBS candidate and the already existing AAC ELD. I will also go on to give you some data points on ELD performance and licensing situation. And then I will give you a little bit of information, which I think it's relevant right now about the ecosystem and where this can already be used, how it can be used, and some use cases and application cases that can be interesting for you to know. So why we want to use Full HD voice? It's clear we want to have communication as if we were speaking to someone in the same room. And well, of course, the first application case where this has been put in practice are hi-fi or high-end video conferencing systems like the telepresence systems that you are seeing in the picture, using 3 channels of our AAC low delay codec. Actually, this AAC low delay, as many of you may know, it's a part of the TIP standard, and it's sort of the standard for high-end video conferencing systems. And Fraunhofer envisions to update this situation with the evolution of this low delay, which is the enhanced low delay, this ELD codec, and not only for this video conferencing use case, but also to other very promising cases like voice over IP for mobile 4G LTE usage. So bringing actually this kind of telepresence situation beyond the room like that. So from a technical point of view, what we understand from Full HD voice is basically related to the audio bandwidth. So we will agree that this plain old telephone service is like the audio from last century. Then we moved on to this nice HD voice with nice codecs like AMR wideband and G722, which is a nice starting point, but why should we really compromise with using up to 7 kilohertz and not use the complete audio bandwidth, which is basically what Full HD voice does, providing CD-like quality and, of course, a superior audio quality compared to HD voice itself. So basically, we want to migrate from intelligible to co-presence. So general high-level requirements for achieving such a performance would be, as I said, high audio bandwidth, of course, low delay, reasonable bitrate usage, and also this is maybe not so much taken into account in many use cases, is the fact that multi-channel and spatial audio is also more and more relevant topic, not just the stereo, but also if you go to a mobile environment, the fact that you can render multiple audio inputs into, for instance, headphones or this kind of binaural rendering. And these kind of features are also very important and also taken into account in the ELD ecosystem. And last but not least, even if it's not a technical issue itself, a clear licensing and IPR situation is, of course, of utmost importance. I wanted to show you this slide basically to highlight, and this is from an ABS feasibility study performed by Ericsson, that basically the upgrade you get from narrowband to wideband is equivalent to what you would get if you would upgrade to really super wideband, which is basically what you can see in this direct MV, WB, and SWB columns. So let's go into these candidates. What's the situation, or how Fraunhofer sees the situation right now? Well, basically it's on the one side, and more in the medium term, the EBS candidate as the codec for voice services in managed networks. While on the other side, and this is immediately available, we position this AAC ELD codec more into the OTT arena for voice over IP applications. And as you see, ELD is already an old boy. I mean, it's not a codec from yesterday. It's been some years around, and now it has some maturity, and we want to really make you aware of the situation, because we think that this can be now massively be used in different application cases. A little bit of history, just for you to have a background where this comes from. Is basically, you see here the evolution of our AAC codec family from the low complexity to HE-AAC version 1 and 2, and MPEG surround if you go to the content distribution area, where, let's say, algorithmic delay is not that important, but basically the bitrate efficiency is what really is optimized. And on the other side, this low delay, enhanced low delay, and ELD version 2 path, where the delay, algorithmic delay, was especially optimized and tailored to give a real time communications codec, but still having a very bitrate efficient performance. I wanted to show you here some results performed by Deutsche Telekom back in June 2010, which basically, based on a Mushara listening test, compared low delay communication codecs. And I wanted to highlight the fact that ELD was the best performing codec for excellent quality, that it's equivalent to achieving 80 points for the Mushara tests. And not only that, but also the fact that other very popular codecs like Silk from Skype and so on did not really match that quality at all, independent of the bitrate being applied. And also important fact, and this is becoming more and more important, is the stereo feature. I mean, ELD really performs with excellent quality at very reasonable bit rates, like starting from 48 kilobits per second. So this is also something to take into account too. So in a nutshell, basically you get CD-like quality using full audio bandwidth with algorithmic delay down to 15 milliseconds. And you get bit rates from 24 to 64 kilobits per second per channel. And with this latest version, version 2, you can really go down to 24 with a stereo, which is basically the latest upgrade we have around this low delay family. Licensing. Well, as you may know, and if you don't, I would like to clarify this. All our AAC codecs belong to a patent pool, which is managed by via licensing. And the good part of having all these codecs inside this pool is that any licensee of AAC flavor is automatically a licensee of all other flavors of AAC. In other words, if you have, let's say, high efficiency AAC in your mobile phone, you don't have to pay more if you want to use our real-time ELD version. It's part of the same patent pool. You don't pay extra. If you're licensee for all the different flavors. I also wanted to highlight all the licensors that are participant in this patent pool, which has already some years of life and never has been challenged. Of course, you can get more information in this link. And now I give you a little bit of context information. As I said in my first slide, we want to bring this telepresence kind of experience beyond the typical video conferencing situation into mobile. And for that, of course, it's important to be present in the operating systems. So back in iOS 4, we already got AAC ELD natively supported. And the best example of usage of this embedded codec into iOS is FaceTime, which is widely used in all iOS and Mac OS devices. You have in this application bulletin quite thorough information about how any application developer can make use of this ELD code to develop any voice over IP application on iOS. And this is more recent. We also achieved to get ELD inside Android. So now it's also ready to be used in millions of devices. And there you have the link also to learn how you have the chance to integrate this ELD for clients on Android. More specifically, it's available natively supported from version 4.1 Jellybean. And for instance, as an example of this potential usage, I put you this Linphone initiative, which basically created a reference model, open source reference model implementation using ELD as codec, using this natively supported ELD. And they also sell as a white label application through Beldan this reference software to third parties. So other future applications where we see a lot of potential and we have been cooperating with lots of partners is the, let's say, connected home kind of environment. Here we had this tattoo project, a EU research project, where we basically had these two scenarios, let's say the low audio quality scenario that was 4 kilohertz mono, and then the high audio quality, which was ELD, using full bandwidth usage, and using 3 channels, so basically left, right, and center. And from the surveys, it was quite clear that people could appreciate the highest quality, and it's also very important. They also stated quite clear that they would be willing to pay more for the DSL service if the provider could offer a service with that superior quality. So it's something that really was valued by the users, by the way they were using, not just some days. It was like a several months project where they had this at home to connect to their relatives and have a, let's say, a long-term experience with this different communications service. Another initiative, this is also a EU project, DConnect. This basically is very similar to WebRTC. It's embedding this web interface with multi-conference. And here we are showing, for instance, how this looks like into a social network inside the SAOP campus run by Portugal Telecom Group. And of course, they are using here AAC ELD, mono, and also stereo. And we have also been conducting several projects and trials with major telecom operators. In particular, this is with one of the major European mobile operators. This demonstrator was basically a multi-conference, multi-point system using iOS and Android. And we had an MCU built from us for demonstration purposes, which basically did some stereo panning from getting a mono signal up mix, so to speak, to a stereo, so that you could identify different users left, right in a reasonable way. And then you get downlink this stereo path. So we developed the applications that were running on iOS and different models of Android. And then we conducted several surveys to get the feedback from business customers and also internal telecom operator employees. And really, the quality difference between normal telephony and this over-the-top solution was really impressive, even compared to Skype. I mean, 90% of the people really could differentiate the quality easily. So coming to conclusion, FullHD voice, ELD, delivers CD-like quality to phone calls. There are two options for super wideband. In the middle term, you have EBS for the managed voice services, but you can use AAC ELD right away for mobile applications, for professional video conferencing systems immediately, and it's already there. As I said, de facto, ELD can be used by any application developer. You don't have to pay for the software as long as you use it from the operating system. And as you know, the patents on the codec itself are paid by the manufacturer of the devices. So any application developer actually could make use of ELD sort of free. So please make use of it. And you have it already in the iOS and Android platform, so it's ready for you to use. So thank you very much, and ready for any questions that you may have.